we've been working with the normal distribution, and what we need to do now is start working with the t-distribution. And the reason for that is because we're not working with the total population, we're working with the sample, or only a portion of the population. Recall, and you've probably done this in courses that you've taught, where you've standardized student scores on an exam. And when you do that, you simply subtract from every student's test score, you subtract the mean and then divide by the standard deviation. And that gives us a z-score. We did precisely the same thing when we developed the idea of the confidence interval. So here it is, we have our z-score, and that's equal to x minus mu divided by sigma, which is the standard deviation. Also recall that we can look not only at the distribution of the individual observations, but we can look at the distribution of the mean. And that goes along with the idea that we can develop a 95% confidence interval for the distribution of the mean. So if we're going to do that, then all we need is x bar minus mu, and we're going to standardize that not by the standard deviation of the observations, but by the standard deviation of the mean. In the sample, we refer to that value as the standard error. So sigma sub x bar is also referred to as the standard error. Recall that mu is a population parameter and is going to be constant. Okay, and if that's the case, then x bar minus mu is going to be normally distributed with mean 0 and variance equal to 1. Now, the variance of the mean, we can do the proof of how this works out, and it's relatively straightforward. We just have to go back to the rules of expectation. But that's going to be simply sigma divided by the square root of n, and that's given that both sigma and mu are constants. Therefore, if we take x bar minus mu and standardize it by sigma divided by the square root of n, we're going to get a value that is normally distributed with mean 0 and variance equal to 1. The difficulty that we have is that we don't know what sigma and mu are. Those are population values. Those are not sample values. So what we do then is we define our new statistic, our t-statistic, as x bar minus mu divided by, instead of sigma divided by the square root of n, instead we use the standard deviation of the mean, which is also referred to as the standard error. And that then is our student's t-statistic. Now, the limit as the sample size goes to infinity of t is actually the z-score. And notice, too, that the variance of the mean is going to be equal to the sum of x sub I minus x bar quantity squared divided by n times n minus 1, the quantity n minus 1. Recall that n minus 1 is our degrees of freedom, and we addressed that in the other video. Now, notice what happens if we have two observations and we'd like to include 95% of the distribution of the mean. With two observations, then the standard error for our limits are going to be plus or minus 63.657. If we have 10 observations, it's plus or minus 2.2. 30 observations, it's plus or minus 2.024. 60 observations, it's plus or minus 1.96. And for infinity, it's 1.96. Recall that the z-score, to include 95% of the distribution, was 1.96. So here you can see that as the sample size increases, in the limit you approach the standard normal distribution, you approach 1.96. Notice, too, that that's true at 60 observations, and if you have 30 observations, you're almost exactly there. And then the situation deteriorates pretty rapidly as you fall below 10 observations. And that's where this rule of thumb comes from, that you want at least 30 observations for each parameter that you're trying to estimate. And it's because at that point you know that you're essentially dealing with a distribution that is almost perfectly mimicking the normal distribution. So then, our new confidence interval for the mean is simply going to be x bar plus or minus our t statistic, and we're going to define the alpha value there, whether we want an alpha of 0.05 or whatever, and the degrees of freedom, and then the standard error of the mean. So that's pretty straightforward, and you can consult any t table to get those values, and you have a t table that was handed out in class.